You know what? There's a tiny fairy that lives inside my wall clock. Whenever all three hands perfectly align, the fairy shows itself for just a brief moment. But tell me, how many times a day does that moment truly come? At midnight, the three hands meet at a single point. 12 hours later at noon, the same scene repeats itself. At least twice a day, that much seems certain. But could there be another moment we've missed? Let's start by finding when the hour and minute hands coincide. To describe their motion more precisely, let's use the concept of angular velocity, the rate of change of angular displacement per unit time, indicating how fast it rotates. This is the time it takes to complete one full rotation. The hour hand completes one rotation every 12 hours, and the minute hand completes one every hour. Therefore, the angular velocity of the hour hand is 0.5 degrees per minute, and that of the minute hand is 6 degrees per minute. After t minutes, the hour hand has turned 0.5 t degrees, and the minute hand 60 degrees. The angular difference between them is 5.5 t degrees. For the two hands to align again, this angular difference must equal an integer multiple of 360 degrees. When n equals 1, they first coincide, giving t equals approximately 65.45 minutes. That's about 1 hour, 5 minutes and 27 seconds. However, at that time, the second hand is near the 30-second mark, so the three hands do not align completely. Now, let's bring the second hand and express their alignment mathematically. The angular velocities per second of each hand are as follows. Second hand, minute hand, hour hand. After t seconds, each hand has turned by these amounts. For all three to align, the angular differences between them must each be an integer multiple of 360 degrees. Here, k1 and k2 are integers. Now, simplify the equation. Look at the results. The second and minute hands align roughly every 61.02 seconds. The second and hour hands roughly every 60.08 seconds. But for all three hands to align perfectly, the t values from both equations must be equal. Solve this equation. Since k1 and k2 must be integers, the smallest solution occurs when k1 equals 708 and k2 equals 719. At that moment, t equals 43,200 seconds. Exactly 12 hours. Therefore, every 12 hours after midnight, the three hands align perfectly. Only twice a day, at midnight and at noon. Only then does the little clock fairy reveal itself. I'll show you that fairy when that moment comes. So subscribe and don't miss it. Thank you.